So here we have given a function as f of x equal to x as an identity function. Our goal is to show that the derivative of this function with respect to x is actually equal to 1. So that means we need to show that f prime of x, which is the derivative of the function with respect to x, we need to show that that is equal to 1. So let's try to show that. Okay, and we're going to show that by using the definition of the derivative. So what is the definition of the derivative? If you have a function f of x, right, so that its derivative with respect to x, which we can represent by f prime of x, can be figured out by finding the difference quotient of the function, which is f of x plus h minus f of x, and then everything underneath that, let's say h, right? So this is the difference quotient, and then take a limit as h approaches to 0. We just want to see when h gets closer and closer to 0, where the difference where this difference quotient approaches. So that's what we want to say for this identity function. So if you want to prove this over here, this result, so we want to assume that on this case the function is the function here is identity function x, right? So let's suppose that, or it's already given, so we can easily suppose that f of x equal to x. So now what we can say here is, if we suppose that, we're going to compute the difference quotient. So how can we find that? So to find the difference quotient, we need to know what is the function, which we already have there. We also need to know what is f of x plus h, right? So but how do you find f of x plus h? If f of x equal to x, then f of x plus h can be figured out by substituting x over here by x plus h, which on this case is just x plus h, right? So that's very easy to find out. So if that is the case, let's apply this and then find the derivative of the function. So to find f prime of x, we can then take a to find the difference quotient first. So what is the difference quotient? F of x plus h, which we have just computed, that is x plus h. So write that down, okay, and then minus f of x. So right, that's what we have, and but that's the given function, right? So we can just write that down, which is just x, okay, and then underneath that we have h, right? So this is the difference quotient, and we just need to find the limit of that function when h approaches to 0. Let me just simplify this difference quotient for a moment. If I simplify this can be written as x plus h minus x divided by h, right? So that's what we get, and then x and x is the positive x and negative x. When we combine, we get 0. So in that case, we just get this as h over h, right? Just simplifying that difference quotient. So our goal is to then actually take a limit, right, on this expression h over h. But when h gets closer and closer to 0, you know that the numerator also approaches to 0, the denominator also approaches to 0. So it's like kind of indeterminate form. What do you do when we have an indeterminate form? We try to see if we can cancel out the 0 common factor. On this case, yes, we can, because the denominator is 0, because h is 0, right? H is getting closer and closer to 0. Also, the numerator is approaching to 0. In that case, we can actually cancel out the same common factor over here. And when we do that, actually, this is just equal to 1. And we know that the limit of this constant, right, so this limit of the constant is just what is the limit of the 1? That is just equal to 1, right? So if you want to just make it mathematically correct, I mean, don't want to confuse, maybe this is how you can write it down. And then we just prove that, because this is the function, right? F of x equal to x is the given function, and then we just show that the derivative of this function is actually equal to 1, right? Okay, done. We proved that the given result here.